Hello, everyone. I'm Josip Maričević. I'm part of a team that is developing democratization of academic publishing as a part of Trublo project. The goal of our project is to create a democratic, trustworthy, and efficient platform for academic and open access publishing in order to strengthen the European research area and Open Research Europe, and to strengthen the academic communication and transfer of knowledge. Since knowledge and information represent strategic power, the goal of DAP is to give authors, researchers, and the public more control over scientific knowledge and information, improve research practices, and prevent research integrity violations, such as those seen in proliferation of open access predatory publishers. A major social impact of our project will be the seamless inclusion of citizen scientists, and especially retired and other institutionless researchers and scientists, advancing the knowledge transfers and enhancements. So during the phase 1 of Trublo project, we have developed several components that will enable us to do this. So some of these components that are important from the technical side are the scholarly wallet, and this is the one that will go into more details and present the pilot version of. However, other components that might not be so technical, but are also quite important, and actually without them, our project would not work, is the competitive review model, and of course, the academic success ranking. So now, how did we try to achieve this? One of the important components that we have developed this pilot version is the scholarly wallet. So it's a wallet that enables us to create identities for all the different entities that are using the platform, meaning reviewers, scientists, and so on. And it also enables them to use that wallet to not only identify themselves, but also to receive tokens as a reward, send them, use them, or even track the reputation. So we have, in addition to wallet, also implemented two solidity contracts. One is fungible token based on ERC20 standard. It's also the one that we will show today briefly. The second one is a non-fungible token that will be unique to each entity, and that will be used to track some, let's say, unique stats like reputation and so on for this academic success. The non-fungible token is still not developed. It will be developed in the next phase. So now we'll demonstrate the wallet that we have developed and the token. As you can see on the screen, our wallet has been developed as a Web3 wallet, making it easier for people who use it to interact with different publishers' websites, front ends, and so on. I will now demonstrate the whole process of the wallet, installing the wallet and using it from the start. So as it's a web wallet, we load it as an extension into our browser. Okay, as you can see, now we have the option to get started. Once again, if we have already been using this wallet, we have bought a new computer, or like we had our hard disk die down or something, we have the option to import a seed phrase. However, if you never use the wallet, we want to set up our identity for the first time, we can create a completely new wallet. So in this case, we're going to go with this. Of course, we have to select the password so nobody will be able to access it. Now, what we are doing what you are seeing on screen, I will now show the secret backup phrase for this identity that I've created now. As you see, it's just like 12 words. However, this is something that's called hierarchical deterministic wallet. It's type of cryptocurrency wallet that uses a specific algorithm to generate a sequence of public and private keys. The key feature of an HD wallet is that it can create a tree-like structure of keys, which allows for easy and secure management of multiple cryptocurrency addresses. Now, why is that important for us? As we mentioned, one of the, let's say, important topics here is that you can have pseudo-anonymous identity. For example, you can create a new accounts for each of one of your processes if you want. Once you are a reviewer on another paper, you can create another account. You can create another account. But if in any time you lose your computer, your hard disk dies or something, you can import this backup phrase, and once you're generating new address with this backup phrase, they will always be generated in the same order. Okay, so this is not the best security practice, of course, but for the demo being, I will take a screenshot of this and make it continue setting up the wallet. So now to confirm, I have to, of course, confirm that I've written it down. Most secure thing, let's say, to back it up would be on some sort of offline storage, like write it down on a piece of paper or something that does not burn and put it in a safe, so then, like in case that everything dies down, you can still recover it. Okay, as you see, I've now selected my backup phrase in order. The wallet has confirmed that I have written it down, and now I have created my first wallet. Okay, currently at this wallet, I have nothing. I can see my public address. I can see I can export the private key once again for safekeeping. I will now copy the address and I will send to myself some test tokens just for the demonstration. Meanwhile, the thing that I was telling you about, you now see I have one account with one address. Now I just click create account. I can just put the name second account. Create, I have second account. Also, the important thing to mention here is that for the purposes of development and piloting of democratization of academic publishing, we have set up a test network where we can deploy our tokens, and all the tokens and the test network is based on hashnet blockchain technology. Okay, I can. This is just for demonstration purposes. Why is this important? So as I was telling now, you can have, let's say, with this account, you do the reviews. With this account, you can collect your rewards for participating in conferences and so on. Okay, so for example, here now I have the test tokens. These are fungible tokens that are, let's say, based on the ERC20 standard. I can check out the transaction on the Explorer. Just a second. I go to the Explorer for the testnet, not for the mainnet. Yeah, we have the transaction. We have our transaction. Okay, I can try sending it some. Now I will send it just between one of mine addresses. I will send, say, well, tokens. And those tokens will appear in a few seconds on our second account. we will also be able to see it in this web explorer. What is also important here? Now you can see the transaction. 12 tokens are sent from this address. To our second address, where it's now visible. Of course, the first address is now has the smaller amount of tokens. Of course, we see the activity, both the incoming and outgoing details. Now, what this token is based about, it's the ERC20 standard. What does that mean? It means that this token has to follow some standards to get implemented. Mostly it has to have the same interface towards outside. So each of the tokens, it's unique. It mustn't have any serial number. However, it has to implement methods. So it has to have the mappings, meaning that each address is tracking the number of tokens, as you can see here. And of course, it has to have, at this point, fixed total supply. However, as the project is progressing and we're developing the economy of our model, this supply doesn't have to be fixed. It can be issued or burned at will. Okay, so of course, the ERC20 standard describes what needs to be implemented. So some of the things are, let's say, trivial, like it has to have a name, it has to have a symbol, it has to have how many decimals it can be divided to. For our token, we set it to 18. We think that's like enough precision for everything. Of course, total supply, balance of address. One of the more important functions, ERC20 tokens have to implement the transfer function, meaning that it's the public function that any address can send any amount of tokens to somebody, and to verify that it's actually me sending that address. We're doing that with these private keys that are kept in our wallet and the digital signature. So I say I'm the owner of this address. I'm sending this and these tokens to address B. Now, anybody of you could actually say that if you have access to the API, if you have access to the network, you could say I'm Josip and I'm sending all of his tokens to address B. However, we always have to sign that digitally with our private key. That process, we don't reveal our private key. We just put this digital signature, and anybody can verify, does that digital signature belong to the address that is actually claiming claiming to be. Of course, so this is also part of the ERC20 standard. It is something that is called locking mechanisms. It's familiar for some of you who are maybe into blockchain technology. That means that you can receive some tokens and have them at your address. However, they can be for any reason locked, like time locked or something, meaning that I can send you to address C 100 tokens, but I say that like you cannot spend them all immediately. You can like 10 tokens, 1 token unlocks every month or something, or like 5 tokens will be unlocked after 6 months, and all the rest will be unlocked after 12 months. So with these functions, approve and allowance, we can implement these sort of time locks or even condition locks. Like, for example, a condition lock can be that you have received the tokens, but you're not allowed to spend them until you have completed the review, or the work has been published and you have got at least, I don't know, a few days of published work. It was not revoked and nothing happened. At this point, again, we're not using these functions, however, because of, let's say, the requirement to follow the ERC20 standard, we have them implemented. Okay, of course, there is, let's say, some more administrative work where we can declare the contract owner. that can, if need be, like in case of some, let's say, illegal doings, that the address owner, which can also be a multi-signature. For example, there can be like a board that is directing with the project, and if it's 5 people, they all have their own 5 private keys, and if at least 3 of those 5 private keys agree on some action, they can act as administrator of this contract, meaning that I don't know now, let's say a hacker steals some coins, or if, for example, it comes out that something illegal was published or something like that, or something illegal was done, that those tokens can be freezed and not moved further. Okay, so we have the transfer function. This is the classic one. This is our internals, how when somebody is transferring from one to another, and it's verified that he is actually the sender, that in our mapping the balances change. And of course we have the burn method that we mentioned. Like at this point our token supply is fixed. However, if at one time we want to act, or not we, or like the whole community, it can be a decentralized autonomous organization, it can be dependent on voting or so, that they can burn supply, as you see in this method, or even emit supply. So meaning that we'll be able to have some sort of economic policy, like if we say we now have 1 billion tokens, we emit like maybe 2-3% tokens each year, or we burn the supply because of some event, or if it's dependent on the amount of money coming into system. So all these possibilities exist for us at this point. Okay, so this is the short summary of our tokens.